So what are the top 5 Genai interview questions? Here they are. The first question is very simple. What is generative AI? Have you heard of this before? It's actually not simple at all. A lot of people think that it's just ChatGPT. In fact, there's a lot more to it than just that. And in this video, I'll go through what it really means and everything you need to know in order to pass your interview. As always, we're going to be learning from the best. This guide has been created based on the official AWS Generative AI practice questions. So it's taken directly from the source. We're going to work our way through these questions one by one, explaining them and then providing sample answers. This way, you will have a deep understanding of what AWS are looking for and be able to apply it to your own answers. I'm guessing that most of you probably already know what generative AI is, but for those who don't, here's a quick summary. Generative AI is the type of artificial intelligence that can generate text, images, sounds, animations, 3D models, or other media types using generative models. Generative models learn from input data and then use that knowledge to create new content that is similar to the data it was trained on. The most popular example of this right now is ChatGPT, which is a text-based model that generates text in a conversational style. Other examples include DALL-E 2, which generates images from text, descriptions, and Jukebox, which generates music in various styles. With that being said, let's get into the top 5 interview questions. The second most common question after what is generative AI is, what are the different types of generative AI models? There are many different types of Genai models, each with their own strengths and weaknesses. In general, they can be divided into 2 categories. 1, text-based models, and 2, image-based models. Text-based models are great for generating texts in a variety of formats such as chat, posts, code, and more. Some popular text-based models include GPT-3, ChatGPT, and Lambda. Image-based models are used to generate realistic or creative images from text descriptions. Examples include DALL-E, and Stable Diffusion. Each model has its own unique capabilities and is suited for different use cases. For example, some models may be better at generating factual text, while others are better at creating imaginative images. When choosing a model, it is important to consider the specific requirements of the task and select the model that is most likely to succeed. Sample answer. There are many different types of generative AI models, each with its own strengths and weaknesses. They can be divided into 2 broad categories: text-based and image-based models. Text-based models excel at generating human-like text in various styles and formats. Popular examples include GPT-3, ChatGPT, and Lambda. On the other hand, image-based models specialize in generating realistic or creative images from textual descriptions. DALL-E and Stable Diffusion are some notable examples in this space. The choice of model depends on the specific use case and the desired outcome. For instance, factual text generation may benefit from models like GPT-3, whereas creative writing could be better suited for something like ChatGPT. Similarly, if the task involves generating images, then models like DALL-E or Stable Diffusion may be more appropriate. Ultimately, the key is to select the model that aligns best with the requirements of the use case. Next up, we have question No. 3, which is, how does generative AI differ from other types of artificial intelligence? This is a pretty hard question to answer because there is so much AI out there and it can be hard to distinguish between them. But here's my attempt at a good answer. Discriminating between various types of AI can be tricky, but here's a breakdown. Generative AI, as discussed earlier, focuses on creating new content through generative models. It learns patterns from training data and uses them to generate new content. In contrast, other forms of AI, such as 1. Supervised learning, 2. Unsupervised learning, and 3. Reinforcement learning, take different approaches. Supervised learning involves training a model on labeled data to predict outcomes for new, unseen data. It is like teaching a model to recognize cats by showing it pictures of cats and dogs and then asking it to identify cats in new images. Unsupervised learning, on the other hand, trains a model on unlabeled data to discover hidden patterns or structures. For example, grouping customers based on their purchasing behavior without predefined categories. Reinforcement learning trains an agent to make decisions in an environment to maximize rewards. Think of it like teaching a robot to navigate a maze and find treasure by rewarding it for moving in the right direction. So to summarize, generative AI is all about creating new content by learning from existing data. Other types of AI, such as supervised, unsupervised, and reinforcement learning, take different approaches to problem solving and decision making. Moving on, we have question no. 4, which is, what are some of the limitations of current generative AI models? This is another really hard question to answer because current GenAI is rapidly evolving. What's true today may not be true tomorrow. Here's what I think makes a good answer. Current generative AI models have several limitations. Despite significant progress, they still face challenges in several areas. 1. Bias and fairness. GenAI models can exhibit bias based on the training data, leading to unfair or inaccurate outputs. Mitigating bias and ensuring fairness remains an ongoing challenge. 2. Explainability and transparency. The decision-making process of GenAI models is often difficult to interpret, making it challenging to understand how they generate outputs. Improving explainability and transparency is crucial for building trust and accountability. 3. Safety and security. GenAI models can be misused for malicious purposes, such as generating harmful content or impersonating individuals. Ensuring responsible use and addressing potential risks remain critical considerations for data privacy and security. Training GenAI models requires large amounts of data, raising concerns about privacy and security. Protecting sensitive information and ensuring responsible data usage are essential. 5. Generalizability and robustness. Current models may struggle when generalizing to new domains or handling unexpected inputs. Enhancing robustness and adaptability to diverse scenarios is an area of active research. As the field advances, it is crucial to continue addressing these limitations to ensure the responsible and beneficial development of generative AI technologies. Finally, we have the last question, which is, what are some use cases for generative AI in your experience or in your research? This is a pretty easy question to answer. You should have a few use cases in mind before going into your interview. Here's a few to get you started. Some exciting use cases for generative AI include healthcare, where AI can analyze medical images to detect diseases earlier and more accurately than humans. Finance, where AI can detect fraud, assess credit risk, and provide personalized financial advice. Retail, where AI can analyze customer data to create targeted marketing campaigns and recommend products. Manufacturing, where AI can optimize production processes and predict equipment failures. And entertainment, where AI can create realistic special effects generate video game assets, and personalize movie recommendations. Additionally, generative AI has potential applications in education, energy, agriculture, and more. The possibilities are vast and continue to expand as the technology advances. Sample answer. One compelling use case for generative AI is in the field of healthcare. Imagine a world where AI-powered tools can analyze medical images such as CT scans and MRIs to detect diseases like cancer at an early stage with greater accuracy than human radiologists. By leveraging generative AI algorithms, we can train models to recognize subtle patterns and anomalies in medical images that may indicate the presence of diseases. These AI-assisted diagnostic tools can help doctors make faster and more informed decisions, leading to improved patient outcomes. Another exciting application of generative AI is in the area of drug discovery. Developing new drugs is a lengthy and expensive process that often takes years and billions of dollars. However, with the help of generative AI, we can accelerate this process significantly. AI algorithms can analyze vast amounts of data related to molecular structures and drug properties to generate new drug candidates that are more likely to be effective. This can potentially lead to the development of life-saving drugs for rare diseases that currently have no cures. Moreover, generative AI can also help in personalizing treatment plans for patients based on their individual characteristics and medical histories, by understanding the unique needs of each patient. AI-powered systems can recommend customized treatment regimens that maximize efficacy while minimizing side effects. Overall, the potential applications of generative AI in healthcare are vast and hold immense promise for improving disease diagnosis, drug discovery, and personalized medicine. That's it for the top 5 Genai interview questions. If you want to go deeper into the world of generative AI, make sure to check out my full course. See you next time!